Once around Nemesis. Well, this story really goes all the way back to a basic question, which is, was the sun born alone? And the sun appears to be a solitary star with its family of planets, Jupiter, Saturn, Uranus, Neptune, and the small inner rocky planets, shown to scale in the image on the right-hand side there, along with a number of other sun-like stars and a couple of red dwarfs, Schultz's star A and Proxima Centauri there. And we know that some of these other star systems are multiple. The Alpha Centauri system is 3 stars. The A and B stars are sun-like, and the third member, Proxima Centauri, Alpha Centauri C, is a small red dwarf. And it was thought for a long time that it was very common for stars to be in multiple systems, binaries, triples, and so forth. But actually, that was probably down to it being a bit biased. We were looking at the stars that were easy to see, and those were over-representing the giant stars, the massive stars that were formed in large associations, born into big open clusters, where nature finds it such that it's got a lot of mass to play with. It's able to form a lot of big stars, and a lot of stars tends to mean a lot of multiple systems. Whereas the majority of the smaller stars now seem to be being born separately, away from many others, and at least 50% of them seem to be on their own. So a bit of a change in thinking on that one. But the question is, could the sun have a companion, perhaps a small red dwarf that we haven't spotted yet? And if not a red dwarf, then perhaps a brown dwarf. These brown dwarfs are the missing link between ordinary stars and giant planets. We have on the diagram here the sun at the top left, then a red dwarf star, and then down at the bottom right we have the Earth and Jupiter. So the Earth is about 1% the mass of Jupiter, so 0.01 mj. Jupiter, of course, 1 mj. The Sun, 1,050, over 1,000 times the mass of Jupiter. And a small red dwarf star would come in that range, 75, perhaps up to 500 times the mass of Jupiter, half the mass of the Sun. But below that 75 Jupiter mass limit, you don't have enough gravity to create the pressure and temperature to trigger off the ordinary hydrogen-hydrogen fusion reaction that creates all the energy to make a normal main sequence star. And so there is this region between 75 Jupiter masses down towards the mass of a gas giant, where you have these intermediate objects called brown dwarfs. And we normally limit the range from 13 to 75 mj Jupiter masses. Below 13, it would be a large gas giant planet. And the reason for that distinction is that the small brown dwarfs, 13 to 75 mj, are able to do a little bit of nuclear fusion in their cores using the slightly heavier version of hydrogen, so deuterium, hydrogen with an extra neutron in its nucleus. It's able to do some fusion reactions using that, and also to some extent some of the lithium that might be present can get consumed, liberating a little bit of nuclear energy. But below 13 mj, that doesn't work at all, and so really you have a planet. And so that's the distinction. Now, we've got quite good at finding these brown dwarfs in the last 20 years or so. One of the first ones was picked up by direct observation using Palomar and the Hubble Space Telescope, shown there, Gliese 229b. So Gliese 229 is the red dwarf star, and B is the small brown dwarf companion to it. And at the time of pulling these slides together, we'd got confirmation of 1,800 brown dwarfs out there in the galaxy. And indeed, that number is rising all the time. So it'll be into the thousands before very long. But it's not as many as we were expecting. It's about the same number of brown dwarfs as small stars, about 1 to 1. And we were expecting more, perhaps 6 times as many, on the basis that nature finds it easy to get enough material together to form small objects and harder to make larger ones. So we get very few giant stars. And as you go down the mass scale, you get more and more, with 70% of all stars being red dwarfs. Now, that's partly because they're easy to form and partly because they live a very long time. So the giant stars soon die and blow up as a supernova or end their lives in other ways. But nevertheless, we are finding a lot of these. So it's an intriguing possibility that perhaps a star like the Sun might have either a gas giant companion or a brown dwarf. And the reason that people started suggesting this sort of idea was because of the long period comets. We have different classes of comet within our solar system, these dirty snowballs that approach the sun, melt, boil off material and develop tails stretching many thousands of miles, millions of miles into space in some cases, pointing away from the sun as they are blown by the solar wind. And we have some of them in the relatively near part of the solar system, orbiting round in 5 or 10 years, perhaps in lock with Jupiter, the so-called Jupiter family comets, perhaps associated with the asteroid belt between Mars and Jupiter. We have others that go further out and that are associated with the Kuiper belt, of which Pluto is a member, the second asteroid belt out there beyond Neptune. And those can be in orbits that take anything around 100 to a few hundred to 1,000 years or so. Beyond that, though, we have the long period comets that take orbits of 1,000, perhaps 100,000 astronomical units out away from the sun, all the way out to maybe 1.5 light years to what's known as the Oort cloud, which is thought to be a reservoir of icy cometary nuclei, dirty snowballs left over from the original solar nebula that is distributed in a random pattern, roughly spherically around the sun, and that the perturbations and the near misses in the Oort cloud occasionally tip one of them into a much longer thin orbit diving in towards the sun, and that can create a long period comet. Now, in many cases, we describe the orbits of these comets as coming in at random, but there was a suggestion that there was a bias, as I've shown in this diagram here, with the close approach, the perihelion, where the comet comes close to the sun, being all rather one-sided, and the aphelion, where the comets go deep out into the Oort cloud, all being tilted, or more commonly tilted away from one side towards the other of the Oort cloud. And this was thought to be very suspicious. Now, echoes of that have recently occurred with the discovery of Sedna, an object in what's called the scattered disk, out beyond the orbit of Pluto, beyond the Kuiper belt. Sedna was the first of a number of discoveries in very long elliptical orbits. So the Kuiper belt and Pluto are at about 35 to 50 astronomical units. Neptune is at about 30. So it's a region just beyond Neptune. But Sedna, at its close approach to the sun, its perihelion, is 76 AU, and it goes out to 937, nearly 1,000 AU. And that is the inner edge, perhaps, of where we would see the Oort cloud beginning to take over. It's a very long orbit, takes 11,400 years to complete one lap. And Mike Brown of Caltech, who's been very interested in the Kuiper belt objects, discovered Eris, that set us on the path of wondering what a planet really was, because it was originally felt to be larger than Pluto and orbiting around the sun out there in the Kuiper belt, and a potential planet candidate. Well, he had a look at the orbit of Sedna, and to give a little quote here, he said, Sedna just shouldn't be there. There is no way to put Sedna where it is. It never comes close enough to be perturbed by the sun, and it never goes far enough away to be affected by other stars. So it's in this no man's land between the strong influence of the sun, the Kuiper belt, and interior to that, the rest of the planetary realm. It's in this outer region, the so-called scattered disk. And as we found more objects, the sednoids that are in similar orbits, a pattern began to emerge, very similar to the pattern that I was talking about for the long period comets, with all the elliptical orbits being tipped in one direction, as if there's something wrong with the other side of the solar system over there to the right of the diagram. All the close approaches, the perihelions, are very closely clustered around one region near the sun, and the elliptical orbits all spread out on the far side. And so Mike Brown postulated that there was a ninth planet in the solar system controlling all of this, perhaps a gas giant that we hadn't discovered, perhaps something else, and that this was corralling the long period comets and indeed the sednoids all over to one side of the solar system, forcing their perihelions to cluster away from the orbit of planet 9. Otherwise, they would encounter it and be unstable. Well, we then went on and discovered some more objects. This one, 2014 SR349, which confirmed the idea, brought the probability that this was random chance up to around 97% in favor of there being an effect and 3% randomness. And then we found 2013 FT28, which is here, which confused everybody because, well, it's still managing to avoid Planet 9, but it didn't really quite fit the pattern, if indeed Planet 9 is in such an orbit. Well, very, very interesting. Maybe something is going on. And another proposal back in 1999 was again that there was an outer planet, Tyche, the Greek goddess of fortune, the good sister of Nemesis. And this was suggested to be 4 times the mass of Jupiter, so not massive enough to be a brown dwarf, a really large gas giant, in an orbit maybe 15,000 AU, a quarter of a light year, taking 1.8 million years to go around the sun. Very long distance, explaining why we hadn't been able to see this object. And it would be pretty chilly out there. The only source of heat really wouldn't be getting much heat from the sun, would be the original heat trapped within the body as a result of fusion, of formation, not from any nuclear fusion, and perhaps a little bit of radioactivity if it had managed to pick up a load of radioactive isotopes early on in the formation process, that could still be generating heat through radioactive decay. And so it was postulated that it might be at about 200 Kelvin, minus 73 degrees centigrade. So an interesting idea. Now, all of these suggestions, the long period comet, the existence of Planet 9 or Planet Tyche out there, were also the subject of speculation based on a completely different line of reasoning. And that was the pattern of mass extinctions over the last 550 million years or so. Complex creatures have evolved from the Cambrian era all the way through to now, and each seems to generate an increasing number of diversity of species and families of creatures, leading up to a peak. And then something bad happens. It seems that that era ends abruptly, and the eras themselves are, of course, defined by the fossils. So the end of a given era is the end of a line of fossils, in the fossil record, which seems to disappear really rather abruptly in most cases, as if something catastrophic has occurred. And just looking at the pattern, the human brain is very, very good at spotting patterns in the data. And as you look at this, you do start to feel that there is something going on, that there is a repeating pattern hiding in the data. And you can do all sorts of spectral analysis on the rates of mass extinctions and so forth. And if you do that, then it's fairly easy to come up with the feeling that there is a 26 to 27 million year repeat period in the disappearance of all kinds of creatures. So this is everything from the large vertebrates, the invertebrates, the protozoan, all sorts of different species of different categories seem to be suffering about every 26 to 27 million years. Now, it was suggested that this might have an origin beyond the Earth, and that one possibility could be associated with impacts of asteroids and space rocks coming in and hitting the Earth. Well, at the time that this was originally suggested, back in the 80s, there were only a very small number of craters that were proven to be the results of impacts, and just two events that seemed to line up with known craters, and that was the Cretaceous to Paleogene transition 66 million years ago, with the impact that Alvarez hypothesized and located at Chicxulub on the Yucatan Peninsula in Mexico, where a 20-kilometer sized object smashed into the ground at hypervelocity, creating the most enormous explosion, a shockwave traveling halfway around the world, wiping out almost anything that it came across, huge amounts of material being vaporized and melted and blasted out of the atmosphere to rain down as molten glass all over the world, setting fire to just about every tree on the planet. So a true disaster of epic proportions, and one of the largest mass extinctions immediately followed. That was 66 million years ago and is represented in the bottom picture. The top two pictures are the craters. At the right, Popeye, and at the left, a schematic of the Chesapeake Bay impact sites that date back to 33.5 million years ago, which is the Eocene to Oligocene transition point in the fossil record. And it seems there was another mass extinction, and that it was perhaps associated with more than one impact event. Now, we've been identifying more and more craters and being able to date them more and more accurately. And so we can have a look at a chart of the crater formation rate on the Earth, which is shown with this orange trace from the left-hand side being now, going back over 250 million years, with the large impact craters, Popeye and Chesapeake, Chicxulub that I've already mentioned, and some older ones there marked with the arrows all the way back to Manicouagan there in Quebec 215 million years ago. And we see a pattern there. Is there a repeating interval between them? Well, you can see that there's a possibility that the interval between those peaks might be something that was of the order of 25 to 30 million years between them. There's 30 million between the Popeye event and Chicxulub. There's 26 million between the some of the other gaps. It's plausible. And in fact, if we compare it with the interval with the extinction events, then there does seem to be a very similar pattern. The graph on the left is extinction of entire families plotted going from 0 to 250 million years ago. And I think you can see that some of the peaks line up, but not necessarily all of them. So maybe this is not the whole story, but maybe it's part of the story that the impact craters have created some, if not all, of the major extinctions. Well, all of this taken together really leads us to having a look at the original Nemesis hypothesis, which actually predated some of the events like the discovery of Sedna. But I put it in this order because I wanted to lead up to this point. Two independent teams both published the same idea that the sun might have a red dwarf or substellar companion out there 1.5 light years away from the sun in an orbit that was 95,000 astronomical units, so very, very distant. And this was back in 1984 when it was first suggested, before really we'd even all agreed about Chicxulub and the impact of the asteroid that took out the dinosaurs. And the idea was that this object named Nemesis could be orbiting out there, and at that distance, it would be ploughing through the Oort cloud. If it was on a long elliptical orbit, it would make periodic transits through the Oort cloud, and as it did so, disturb the vast numbers of comets out there and cause them to pick up different trajectories, many of which would come hurtling into the inner solar system, creating a giant storm of comets. Now, they would take quite a long time to fall in, depending on how they were deflected. They could take 100,000 years to come in from out in the Oort cloud. Maybe they could even take 1 million or maybe even a few million years to fall into the inner part of the solar system. And so the impacts, such as they might be, on planets in the inner solar system, such as the Earth, could be spread over a considerable period of time. They don't all have to happen at once. And this might explain why there is some evidence that the impact spikes might be rather blurred, because it might have taken a whole series of impacts to have ruined the climate, created that nuclear winter. And one of those was perhaps the most recent. This was 14 million years ago. The climate had been, in the mid-Miocene period, a very, very nice warm climate with life being highly abundant. And then suddenly, in terms of the fossil timescale, things changed. The climate cooled dramatically. There was a spike in oxygen 18 isotopes detectable in the fossil record. And on the seafloor, we find heavy metals like barium and uranium. Now, those could be the product of volcanic eruptions bringing those materials to the surface, but it's just as likely that they were delivered by asteroid impact. And certainly the change in the climate seems associated with a fairly substantial extinction at this mid-Miocene disruption of the biosphere, as it's called. And if we look at the cratering that we know about, there are two craters, Nordlinger Rice, 24-kilometer crater in Germany, and another one that is the Stenheim crater, 3.8 kilometers across. Now, these date back to around about 14.8 million years ago in the case of the Nordlinger Rice, and the Stenheim crater was originally thought to be part of a binary asteroid that came in and created the two together, but it's been dated as slightly younger by about 500,000 years. But there's no reason to exclude that as being part of a shower of impacts that would have come in perhaps from the latest disruptive Nemesis event, as Nemesis ploughed through the Oort cloud and sent all this stuff hurtling our way. And what you've got to remember with craters is that 70% of the Earth's surface is covered in ocean, so we only get to see and detect just less than a third of the total impacts. So if we see two, there were probably going to be about half a dozen fairly large impacts, some of which landed underwater and we don't get to see them anymore. They've been silted up. So it could be that 14.8 million years ago, there was a quite significant bombardment of the Earth. And if that was caused by Nemesis coming to perihelion, sweeping through the cloud and sending a load of stuff our way, well, 14 million years later, it would be half its orbit further round. If it's taking 26, 27 million years to do a lap, then 14 million years is about half of that. And so it would be at aphelion, 95,000 AU, 1.5 light years away from the sun at the moment, and be very hard to detect. But if we put all of this together, we take the orbits of the long period comets and the potential asymmetry in those, suggesting that they have their perihelion on one side of the sun, then perhaps the perihelion of Nemesis is on the other side, and that would tell us which direction to look in terms of its aphelion when it's far from the sun. That would be on the other side of the sun to where it makes a close approach. And so we're perhaps talking about somewhere in the constellation of Hydra, just below the ecliptic. Now, Hydra is quite a big, long, thin constellation, but the math sort of suggests a plane on the sky and a region quite a few degrees long that seems to land roughly in this area marked out by the long constellation of Hydra there. So that would be the place to go look to see if you could spot this substellar companion of the sun, Nemesis. Well, people have been looking, but the question really is, why have we not found it? And the first part of the explanation is that what we will be looking for in the 19th century and the 20th century surveys that looked for nearby objects would be the high proper motion across the sky. The rapid change of position of an object gives away the fact that it has a high proper motion, a high relative velocity across the sky compared to our motion round the galaxy. And so it appears to change position against the background of stars very rapidly. And the animation here and the image, that's Barnard's star, which is one of the objects that has the highest proper motion detectable, changing its position just over a few years there against the background. But a companion of the sun, Nemesis, wouldn't really show up in these studies because it and the sun would have the same average velocity around the galaxy. And in such a long orbit, its orbital velocity would be pretty slow. So we really would probably not have noticed it in all of these early surveys. What we really needed to do was not look for an object that was moving, but to look for an object that was warm. Warm because of that heat of formation. Warm, perhaps if it was a red dwarf star, it should be glowing in the visible part of the spectrum. But if it was a brown dwarf or a large gas giant, the residual heat within it, depending on how it formed and how massive it was, whether it had carried out a limited amount of deuterium or lithium fusion as a brown dwarf or not, but certainly the heat of radioactive materials within it would warm it up above the background temperature. And so it should be visible in the infrared, giving off thermal radiation. Well, the IRAS satellite back in the 1980s surveyed the sky looking for infrared sources, failed to find Nemesis at all. That was followed by the 2MASS survey, 97 to 2001, that was active, and that also failed to detect any large unknown bodies that were glowing with heat in and around our solar system. So they failed to find anything. The latest is the WISE spacecraft, and this has been used to track down many brown dwarfs out there in the galaxy, recently finding some just 6.6 light years away, just a little further away than Barnard's star. so relatively near to the sun, but not Nemesis. Nemesis would be round about that 1 to 1.5 light years away, much closer in. And we should have seen it if it was there. Certainly anywhere out to about 10 light years, WISE would have found anything warmer than 150 degrees Kelvin, so glowing away in the infrared. And it was able to rule out anything larger than Saturn all the way out to 10,000 astronomical units, or Jupiter-sized objects out to 28,000 astronomical units. So I'm afraid that ideas of planet Tyche or planet X or planet 9 being a large gas giant planet like Jupiter in an orbit of 15,000 AU, well, we just haven't spotted it, so it cannot be. We would have found it by now. Well, when this happens and people have a hypothesis, they're often quite stubborn about letting go of it. And so we get a phenomenon that I've noticed before, and my talks about the planet Vulcan and other ideas have echoes of this in them. So do check those out as well. But this is the one in this case, Nemesis lost. Maybe Nemesis was once in orbit around the sun, and maybe it isn't there now, which is why we can't find it anymore. Maybe it was lost back in the past, a long time ago. And it could well be that its orbit taking it out to 1.5 AU is so far from the sun that it's almost at the point of being unbound, uncoupled by the sun's gravity. In fact, the tipping point between being bound by the Alpha Centauri system with its 3 stars and rather larger mass in total than our sun is somewhere around about that 1.5 AU. The so-called Hill sphere of the sun is not much larger than 1.5 astronomical units, and the Hill sphere is the region where the sun's gravity dominates over the overall gravity of all of the rest of the material in the Milky Way. So beyond that 1.5 AU light years, you would become uncoupled from the sun. So maybe Nemesis has detached itself and gone a-wandering. And one possible reason that that might have occurred is that we do occasionally have stars that pass by the sun, and a passing star coming fairly close to the sun would alter that balance. And if it came closer to Nemesis than the sun was, it could easily strip it away and bind it. And Schultz's star is a case in point. Schultz's star, I did a video about that as well. Go check that out. But that came past us just 70,000 years ago. It's a pair of objects. There was Schultz A and Schultz B. A is a red dwarf and B is one of those brown dwarfs. And they came past close enough to perhaps affect the Oort cloud in terms of sending comets our way, and could potentially have interacted with Nemesis or any of these giant outer hypothetical planets in the process. Now, the fact that it was 70,000 years ago would have certainly perturbed the comets. They could still be comets from that event falling in towards us. As I said, it can take 100,000 or even 1,000,000 years for comets to come into the inner solar system. So maybe there's a whole stream of comets on their way, triggered by Schultz's star. But it's probably too recent in this particular case to be responsible for removing Nemesis. But other stars have come close in the past, in hundreds of thousands or millions of years. And so, you know, any time in the last 10 million years, it will be perfectly reasonable for our close approach to have stripped Nemesis away from us. Even if it didn't, it might have kicked it into a slightly perturbed orbit. And Muller, one of the proponents of the Nemesis hypothesis, suggested that this might have happened a number of times, changing the orbit of Nemesis, and therefore accounting for the slightly wobbly nature of the extinction pattern. And that's an interesting point, because it could be that the orbit has not always been identical. Certainly the orbit of things like Schultz's star was affected, or the trajectory of it was affected, by the close pass of the sun. So maybe, maybe not. But what about other explanations for all of this? Well, there are some interesting ones which I wanted to mention. One of them is that those close passing stars could be responsible for the whole thing. Maybe we encounter passing stars with a degree of regularity. And one option for that is that as the sun orbits round the center of mass of the Milky Way, we take about 230 million years to do a lap. But as we do so, we periodically pass through the speed humps, the spiral arms. These are not solid structures. They are temporary over-densities, rather like a knot of traffic forms on the motorway or the freeway for no reason at all, other than a pressure wave traveling through the cars, being transmitted by the close proximity of dense traffic. And this can happen with stars as well. They interact with each other where they're over dense, gravity is a bit stronger, and you get a sort of pile up, and the sun will pass into one of these spiral arms, be accelerated towards it by the over density and the excess mass, and then slow down again as it comes out the other side. But in the process, it will be close to a lot more stars, and so perturbations of the Oort cloud and storms of comets could be one possibility to result from our passage through these spiral arms. And maybe this is accounting for the entire effect. Those spiral arms are not entirely regular and symmetrical. So again, comet storms coming at some interval, but a slightly variable interval, is a very good candidate. Another one is that as we travel around the sun, with the sun on its journey around the Milky Way over 230 million years, we wobble up and down. We oscillate about the galactic plane, going perhaps 250 light years above the plane and then below it, with a period of around 32 million years, which is not too dissimilar from the number that we've been looking at. And so maybe the galactic plane itself has an overdensity of matter lying in a flat sheet, and that as we cross through the plane, the Oort cloud gets disturbed. And again, we get a storm of comets coming into the inner solar system for a few million years, every 30 or so million. And maybe that is responsible for this pattern in the mass extinctions. Now, it explains the mass extinctions, doesn't so much explain some of the other mysteries of Sedna and the long period comets, but these are interesting possibilities. But one that I came across was related to dark matter and the plane crossing of the galaxy. It's conceivable, and there are quite sophisticated physics theories, that there might be a thick layer of dark matter along that galactic plane, just 1 or 2 light years wide. And that as the Earth passes through there, not only will it have a gravitational effect and perturb the Oort cloud, but it could affect the core of the Earth. And as we pass through, we would get a significant increase in dark matter streaming through the Earth. Now, normally it's inert, it passes straight through ordinary matter, doesn't react hardly at all. But reacting just a little bit might be enough to increase nuclear reactions going on in the core of the Earth. It might speed the decay of radioisotopes. It might trigger nuclear fission events, and it certainly might release more energy. And a pulse of energy being released in the deep core of the Earth would gradually find its way up out of the inner core to the outer core and into the mantle and create additional mantle heat plumes. And additional mantle heat plumes could burst forth to the surface and trigger volcanic eruptions or even super volcanoes, flood basalt events. And it seems that some of those mass extinctions are associated with flood basalts, not necessarily with impact events. Sometimes there appear to be both going on at the same time. So maybe this is part of the explanation, that the flood basalt events are being triggered by the interaction of dark matter with the Earth's core. Now, this is entirely theoretical. There's not really any proof of this, but it just goes to show that there's a lot more that we still have to learn about all of this. And to finish off with, I just wanted to mention the Nibiru cataclysm. This is a predicted encounter between Earth and a large hypothetical planetary object called Nibiru. The name comes from the publications on the ancient astronaut basis of Zecharia Sitchin and his interpretation of Babylonian and Sumerian mythology. I say interpretations, well, these are exaggerations, really. I'm not a fan of this, but I thought I'd mention it anyway because it's a chance to introduce a picture that I just love. The picture on the right is often claimed to be Nibiru coming towards us, ready to cause the doom of mankind, but it isn't. It's an object called V838 Monocerotis, and this is a truly fascinating object in its own right and deserves its own episode. So when I get around to it, I will be doing once around V838 Monocerotis. So do have a look at that. But the Nibiru theory stems actually back to 95 with Nancy Lauder and her Zeta Talk website. It's unbelievable. She claims to be in contact with extraterrestrials from the Zeta Reticuli star system through a brain implant in her head, and have been chosen to warn mankind that Nibiru is on its way and are going to sweep through the solar system and disturb the orbit and the orientation of the Earth's poles with a near miss, not a collision. But she claimed that it was going to happen in May 2003. And, well, that date has been postponed and postponed and postponed because it didn't happen. And, well, we're all still here, aren't we? And I just wanted to point out that there is one really strong piece of evidence that we shouldn't ignore, and that is that we have sent 5 different spacecraft out of the solar system: Pioneer 10 and 11, Voyager 1 and Voyager 2, and the New Horizons spacecraft are all heading out of the solar system, and we're still in contact with New Horizons, Voyager 1 and Voyager 2 as they exit the solar system. The distance of Voyager 2 is now about 120 astronomical units, so well out beyond Neptune and Pluto, getting out into that scattered disk region. And we have detected no deviation of the flight path that we can't explain through physics means, caused by the unknown gravitational effect of any large object out there in the outer part of the solar system. There was at one stage an effect called the Pioneer anomaly, where the Pioneer spacecraft appeared to be veering off course, and that too caused a lot of speculation about a gravitational influence of an unknown body, but it was all pinned down to asymmetrical heat release from the onboard nuclear isotope power generator of the spacecraft, which was just giving it a gentle push in one direction more than another because of the release of infrared radiation due to one side being warmer than the other. And once that was taken into account, everything fits. So I'm afraid that all of this speculation seems to be pointing towards there not being an unknown large object out in the solar system. But I really hope we're wrong, and I really hope we do find something. So with that, thanks very much for listening, and I'll bring this one to a close.